Good afternoon, Professor Chen. We all know that the Southeast University has a wonderful School of Mechanical Engineering, which is also well known and has lots of achievements. So could you please give us a short introduction about this school?
Yeah, sure. We had a long history. Mechanical engineering in Southeast University is probably the oldest department. Many other engineering can be traced back to mechanical engineering. Not only in Southeast University, I think maybe also all the many other universities. As you mentioned, we achieved a lot. Let me just give several representative examples. For example, currently we are ranked as the Class A university in China.
That's great.
Yeah, and mechanical engineering is among the top school in Southeast University. Yeah, to sum up, so Southeast University is one of the top universities in China, and mechanical engineering is one of the top-notch schools in SEU.
Well, I've heard that this school conducts a great work in both scientific and practical research. So could you please give us an example of the research fields?
Sure. Research, yeah. We are working on, we are mechanical engineering. We are doing research on both classical mechanical engineering and also cross-disciplinary research. Let me give you a few examples. For the classical mechanical engineering one example is the robotic fish. So inspired by the living fish, we are making a robotic fish.
Biomimicry.
Yeah. So we using 3D printing to make the shape streamlined. We added wireless communication, etc. With all those features, so we can make this robotic fish to swim in a deep water, very complicated environment. Yeah, that's one example of the robotic. This is very classical mechanical engineering research.
That's wonderful.
Right. Yeah. We are also working on the cross-disciplinary research. So let me give you a few examples. For example, we are working on the biomechanical engineering. So one example is we doing research on the so-called microfluidic chips. So the idea is use a very small channels, like the micrometer level, use this chip, this channel, to separate the tumor cell from just one drop of blood.
Micro operations.
Yeah, exactly. So this is one example. Another example is so nowadays people working on self-driving cars. So this one should combine the classical mechanical engineering, the vehicle, and also the self-learning
The artificial,
detection. Yeah, exactly.
artificial intelligence and other fields.
Yeah. So this is another example for the cross-disciplinary. So here I'd like to highlight one research in our school recently. That's for the renewable energy research. So nowadays we have, the carbon peaking and the carbon neutrality goal. So we try to find the renewable energy resources to replace the fossil fuels. Right? You probably know currently most of the renewable research is focused on harvesting from the sun. Why is that? So
The main energy source.
Yeah, you are mechanical engineering, so that's because it's hot. But from the thermodynamics, we can harvest from something hot. We can also harvest from something cold. So we're doing the latter. We harvest from the cold outer space. So once you go through the atmosphere into the deep space, it's very cold. It's close to absolutely zero temperature. Yeah.
Sub-zero
So we have a temperature difference between the Earth and the outer space, like 300 Kelvin. We can harvest, we convert this temperature difference to mechanical work, to electrical work.
Energy conversion.
Yeah, energy conversion, exactly. But not from the hot resource,
From the
but
cold
from the cold resource.
That's
Yeah.
great.
Not just that. More interesting and more excited is another one. So one of the biggest problem of the renewable energy is it's not stable, fluctuate. Like the sun, the solar. At daytime you have sun.
And at the
Sunrise
nighttime,
in the morning,
you don't have
yeah,
any
peak.
source.
Yeah, and that time we don't have anything, right?
Yes, exactly.
So of course, so people have different strategies to deal with this. For example, the battery, right? But we started from a different point of view. We are motivated from the electrical engineering. For electrical engineering, one of the novel element is the H-bridge, so-called. So its function is to convert the AC current to a DC one, right? So from the electrical grid, it offers the AC. But in our daily life,
We use the DC.
we use the DC, right? So that's the key element in the electrical engineering. The key element is the so-called the electrical diode. So some element you can flow current one way very easy, but the opposite
It's
way
hard
very
in the
hard,
opposite
right?
way.
So we are motivated by this thing. We first invent the thermodiode. Yeah. So the heat flow very easy from one direction, but the
And it's
opposite
hard in the
direction is hard.
opposite.
Yeah. Then we combine these thermodiode to build up a so-called thermal H-bridge to convert the theoretical solar energy to a constant temperature difference to drive the heat engine
That's
to work
interesting.
continuously. Yeah,
Yes.
that's one of the most interesting, excited research in our department right now. Yeah. So this type of research, it combines the heat transfer, material, solid state physics, all different
And electronics.
Yeah, electronics, exactly. So different disciplinaries. So I think this is a very representative cross-disciplinary research in our department.
Exactly.
Yeah.
Wonderful. Everything you've just said comes straight out of the science fiction. Now, I also heard that this school conducts research on both microelectronics, microchips, and all the related things. Could you please tell us anything about it?
Yeah, sure. Yeah, microelectronics, microprocessors. Yeah. So when people talk about these things, so you immediately think this is double E, electrical engineering. So why are you mechanical engineering? You're working on chips. Really? Are you kidding? No. Let me.
Because that's all interconnected.
Yeah. Let me explain. Let me give a reason. You probably recently did you watch the Shenzhou spacecraft?
Yes.
Yeah.
Yes, I've heard about it.
Yeah, it came back from the outer space, right?
Yes.
You know, if you watch TV, when the spacecraft re-entered the atmosphere, very high speed, moving very fast, to
And also
compress,
enormous heat.
yeah, compress the atmosphere heavily because of high speed, right? So like on fire on TV, right?
Yes.
You probably guess it's very hot. But you know, for the microelectronics, especially for the microprocessors, the very small one, right? So currently, the heat flux for this small chip is on the same order of the spacecraft when it re-enters the atmosphere, if not higher.
So they're working on a very
Yeah,
extreme
it's
conditions.
very hot. So if you can do an example, right now it's summer right now. You can bring your laptop, go outside, and sit under the sun.
And it would heat up.
Use it, right? I bet after half hour, it will stop work.
Exactly.
Why?
Overheat.
Because the heat cannot go anywhere. So that's the key problem we try to solve from the point of view of mechanical engineering, not the electrical engineering. Of course, the double E major, the double electrical engineer, they work on make it tiny. So currently it's they can make a line width as small as like nanometer, 3 nanometer, 7 nanometers, something like that, right? That's their job. They try to push the limit, make it as small as possible.
Exactly.
But when these lines so small, So you dissipate a lot of heat.
Exactly.
So we, mechanical engineering, take care of the heat. We try to make new materials. We design new architectures. We try to solve this heat dissipation problem. That's why we are working on the electrical microprocessors.
That's interesting.
Yeah.
The research background of this school is truly impressive. I believe that only an excellent faculty could provide such excellent achievements. What is your opinion about it?
Yeah, sure. I agree. The key is the faculty members. For the faculty members from my department, so we recruited faculty members from top universities. For example, UC Berkeley, Stanford, US, and Tsinghua University in China.
The top schools.
All those top-notch universities. So the only reason we visited a new faculty member is we believe that new faculty member will be the next generation leader in his or her field. So we have a very high standard to recruit a new faculty member because we believe the faculty member is the key for research, not just research, to train the student for class.
To cultivate the talents.
Yeah, exactly. So that's why we spend a lot of time and effort to recruit the top faculty members from the top universities.
That's great.
Yeah. So currently we have the ratio between the graduate student and the faculty member is roughly around 5 to 1. That means every 5 graduate students will have 1 faculty member to support them, to train them.
That's convenient.
Yeah.
Well, that's truly remarkable. But are there any other factors that could attract students to come and study here?
Well, as I mentioned just now, we have not only the top-notch faculty members, but also well-designed curricula, advanced labs, and also a lot of student clubs. For the curricula, especially if you are international student, let's say if your Chinese is not so good, we offer English-taught courses. For example, heat transfer physics, finite element analysis, and engineering electromagnetic field, and so on.
That's wonderful.
Yeah. One famous student club in Mackay is the driverless Formula student team of Southeast University. So that club has, if I remember correctly, more than 40 members, and it won numerous prizes.
That's remarkable.
Yeah, and in Mackay, you also have a lot of opportunities for overseas exchange program. For example, you could choose to go University of Michigan in US, University of Waterloo in Canada for 1 semester or multi-semester studying if you want.
That's great.
Yeah.
Thank you, Professor. As we know, the university is celebrating its 120th anniversary this year. Many of the former graduates are participating in the celebration. Could you please tell us anything about the graduates of your school?
Roughly, we have 200 graduate students graduated every year. So among
That's
them,
a lot.
Yeah, among them about 15% are PhD students, and all the remaining 85% are master students. All of them, almost all of them, are recruited by very famous research institutes, universities, and well-known enterprises, including Huawei, HiSilicon, ZTE, etc. That's guaranteed. You can find a very good job.
Companies.
Yeah, very good salary. Yeah. Among all of our alumni, there are 16 members of the Chinese Academy of Sciences, or the Chinese Academy of Engineering. Yeah. Well, mechanical engineering in Southeast University is a place, I think, to change your life. With the knowledge and the skills trained here, I believe you can change the world. So come and join us. Let's change the world together.
That's marvelous. Thank you.
pleasure.
It was a big pleasure
My pleasure
to have a
too.
conversation with you.
Nice to meet you.